Okay, so the recording has been started. So anything which I speak from now will be recorded. Okay, okay. So the session is going to be in two parts. First, focusing on understanding big data, first half, and second half is going to be understanding the Hadoop ecosystem and the architecture. And so everyone except me is muted. Please ask your questions by typing in the questions window, and I'll read out the questions before answering, as well as to get the better answers, please do me a favor that avoid the chat language. All right, because for me it's little difficult. So what I will do is I'll copy paste the question into a text or notepad, and then so that everybody can see the question, and then it becomes easier for me to explain. All right, now so let me just open notepad also. So this is where I'll be writing my notes. Okay, and 24th October, that's today. All right, and okay, so a very warm welcome from No Big Data to all of you. A little bit about No Big Data is that we take pride in saying that we have got a great set of instructors. And the other key highlight of our courses is CloudX Lab. All basically, it's a lab environment provided on the cloud. And since all the big data components require multiple computers to learn, so learning using a single computer is always incomplete. And we provide a lifetime access to LMS. When I say lifetime, it's as long as possible. We do not put any restriction on the usage on the time for which our videos and presentation and the quiz and everything which is in there, it will be available for all the students forever. Okay, and LMS contains all the things including the recording, quizzes, assignments, and the project work. All right, so is my voice okay, or should I be a little louder? Because today I'm trying to be uh, little, little, how should I say, little softer on the voice. All right. So the other part is that if you complete all the assignments which we provide you and you have time and interest in pursuing a real life project, then we provide you an extra project from the real industry. For example, currently we are running a project with Dell whereby we are helping them do the order analysis, the total number of orders they are receiving every day, as well as we are providing them a live analytics into their order management system. Next is that we provide you a course completion certificate if you complete our project and have finished all the quizzes. So quizzes and the last project is mandatory for all, and we provide you a 24 by 7 support. All right, and we have a group for all the alumni. All right, so the course, out of 11 sessions, it is today is going to be the first session. Generally, I would like to make you aware that sometimes our course spills over to 12 sessions because we want to answer each and every topic rather than rush into everything. Okay. So, I mean, rather than skipping the questions and trying to hurry up, we sometimes expand the course to 12 sessions. All right. Great. All right. So my volume looks good. So I'll continue with at this pace. All right. A little bit about me. I graduated from Indian Institute of Technology, Roorkee in 2002 and worked for a company called DE Shaw. And DE Shaw, not many of us know, is a American company, and even the founder of Amazon was from DE Shaw. We worked on big data systems even before the term was coined. So we had a 10,000 node cluster in 2002. After 2006, I built a company called Tbits Global. We we built a document management system for large enterprises, which is being used by many companies, specifically in construction, to manage their documents and drawings. All right. And in 2012, I joined a company called InMobi and built their recommendation system, which used to churn 200 terabyte data. In 2012 to 2014, I was working with Amazon and I built a high throughput system for Amazon.com, which was using the built-in NoSQLs and was basically a platform like Storm to do a lot of parallel computing in real time. So that was my contribution at Amazon, other than building their mobile app. So those were the two things I did. And then I started in 2014, No Big Data. Okay, so the idea behind No Big Data is that there is a huge gap in the industry of in the learning industry, and I think I can make a significant contribution to it. All right. So I thoroughly enjoy converting the complex topics into easier ones, and uh, and that's what we I have put it in these 11 sessions. Okay. So the other partners we have at No Big Data are also from similar domain. All right. Let's start with a simple question to all of you. And this question is important because this is the ground on which we all will be discussing the things from now onwards. So what exactly is big data? What do you understand by big data? All right. Murugesh says that it's a data that are huge and that cannot be processed by traditional tools. Good, good. Mahbub says that it's a huge amount of data. Kamal says huge amount of unstructured data. As per Harita, it's the volume, velocity, and variety. Brilliant, very brilliant answers. Peter says that we have data set that are too big for one computer to be managed over a distributed system. Brilliant, brilliant. So I'll just keep some of the answers out. All right. Is the font visible now? All right. We have another answer from Rohit. Large amount of structured and unstructured data. Great. Okay, Murke says that it also needs distributed architecture for processing. Brilliant. All right, it's in continuation with his definition earlier. And Dirupu says that it's a large volume of data that is difficult to process with normal tool. Brilliant. Great. Great set of answers. All right. All right. Anand says that huge amount of unstructured data, which is huge in volume and velocity, and required multiple computers to process. Brilliant. Great, great set of answers I'm having. So the bigger answer, I'm generally keeping it in the notepad so that all of you can see at later point of time. All right, great. So here is what I have consolidated. All right. So big data in very simple words, data of very big size. I'll come to the definition of very big data again. That cannot be processed using usual tools, and for which you require distributed computing or distributed architecture. And data could be of any kind. As usual, whenever we say data, it means data of data can be structured or unstructured. All right, let me take a step back. So the first point, which is data of very big size, is very general. It doesn't say anything concrete. How big is it? Supposed to be 1 terabyte, 1 gigabyte, 2 terabyte. All right. So first point is not very concrete. Second point, cannot process with usual tools. Okay. So the next question you would ask is, what do you mean by usual tools? The usual tools I meant here is the the usual file systems, like you have NTFS, you use Windows, you have MS-DOS format, and there are many file systems. Okay, so similarly, the usual tools could be considered as your databases, where you have Oracle, MySQL, Postgres. So those are usual tools. But again, usual tool is very abstract word. All right, because after some time, if Hadoop becomes the usual tools, do we still say it big data? All right, so second point is also not very concrete, and the fourth one, which is structured or unstructured data, that's also doesn't make much of a sense, because data is data whether in whatever form. The most important point here is the third point, which is to process the data. If you need more than one computer, then it is distributed computing. All right, then it is big data. So all of our focus in this 11 sessions is going to be distributed computing. All the components which we have listed in the course curriculum, they roam around the idea of distributed computing, because of change in the paradigm, change in the way the computing is done. There has been lot of tools. Okay, for example, for storing files, we have new tools. For running a program, we have newer tools. And for even do a parallel processing, such as using threads. Okay, using threads, the way the locking mechanism works may not be great as of today without the newer tools, and that's where tools like Zookeeper come in. So we will go over the whole stack, and there is a common thread amongst these 13, 14 components which we are going to discuss in this course. And the common thread is distributed computing. All right, we will go into the details of almost every concept which is required in distributed computing. So this course is quite exhaustive and aggressive when it comes to the big data. All right, now there is one thing I have forgotten. I have not uh, gone through your introduction. Anyway, we will be sending the discussion of this class to all of you along with your questions. So in that and that time, I'll again go through everybody's background. All right, all right. That's how I would get to know. All right, now that was a little bit about big data. So, one more thing I want to emphasize right now is please feel free to ask your questions at any moment of time. All right, do not wait for me to finish the topic before you ask a question. I will answer your question only after I finish the topic. That's another thing. But do not wait for this for me to finish a topic before you ask a question, because you might drop a question, you might forget what is it that you were asking. All right, so the whole idea about these sessions is the discussion, because all of this information is spread across the internet. You can even gather each all of this information. The main point why these classes or why my classes are so successful is because of because candidate get their questions answered. All right, and because that is something which is very difficult to get done by your own research most of the time. All right, so when we talk about data variety, the common thing which people ask after my first definition is, what do you mean by structured data or unstructured data? So structured data is where you know what are the fields in the input and you know what are the data types. So you know clearly that these are the fields in the input and these are their data types, such as MySQL. So or such as any databases where we clearly know that this is the structure of the data. Okay. Second is unstructured data. Under the extreme, I'm going to the other extreme, mm, or so the second is the semi-structured data. Semi-structured data means we know that these are the fields in the input, but we do not know their data type. Okay, for example, take the comma separated values, the CSV file. If you open CSV file in the notepad, you will notice that it has values which are comma separated, but there is no information about the data type that is stored in each column. So that's a semi-structured. Third is the unstructured data. Unstructured data, as in neither we know what are the fields in the input nor we know what are their data types. Okay, we do not know these things clearly. For inferring this information, we'll have to parse it. We'll have to apply a program, apply a logic to convert the crude data into some format which might be semi-structured or which might be completely structured data. So to convert unstructured into semi-structured, or structured, we might require processing, and we generally call it parsing the data. All right, good. The Next concept which I wanted to discuss is the distributed computing. We talked about distributed computing, but I'll be very specific. Distributed computing means group of networked computers that we make interact together and to solve a single purpose. Okay, so whatever we want to achieve, let's say we want to crack the passwords of the world. So we group the computers together, hand it over. Some part of the passwords are being tried by one machine, some part is being tried by another, and so on. So that was an example of distributed computing, probably the oldest way, the oldest, most commonly used or misused or abused distributed computing. Or let's say you are looking for for a treatment for cancer. Now, you know that there are a lot of permutations of drugs or a lot of permutations that need to be tried to fit in. So what you do is some part of the work you give to one computer, some part of it give to another, and so on, so that all the computers are working together to solve a single problem. So that is distributed computing. The concept itself is actually fairly complex, as you will see now, because the storage itself has to be distributed. Okay. When we store a file, it has to store on the whole cluster rather than on a single machine. And we will see how we'll do it. Okay. All right. Before we have two questions. Now, Rohit says that XML data comes under structured or unstructured. So, XML is considered semi-structured data. We know generally the fields, but the fields, we do not know the concrete. We do not know concretely the data types of various fields. So, XML structure generally comes under semi-structure. Okay. Sumati's question is, could you give an example of unstructured data? Thank you for asking this. I think I missed that part. Okay. So imagine that you are running a website and that website is producing error messages continuously. So although the error messages are produced by the web server and they would have some structure, as in they would have values in separated in certain manner, but till the point you parse them and store them in certain databases, it's all crude. Okay, so the website logs are considered as unstructured data. The website logs need to be parsed as in PARSED. They need to be parsed to clear the to convert the plain text into structured data, plain text into the column format. So that's one example of unstructured data. The unstructured data could be in many forms. Sometimes we also consider a video into unstructured data. For example, if you are having a lot of videos stored in a folder and you want to find out what is the if this video doesn't have all the tags available, you might want to say compute what is there, what is the bit rate we are having, what is the frame per second. So all of this information, to infer this information, will take a long time and would require a processing. All right. So that was the same question from Pankaj also regarding example of unstructured data. And then we have a question from Shyam. So point from Shyam is, text analytics such as Facebook likes, comments, good example of unstructured data. Yes. So when you have lot of comments coming from Facebook, okay, let's say your purpose is to find out find out how many people have given a positive comment and how many people have given a negative comment, and you have to do it from the response of the people, right? So, and the response of people is in the form of the plain text. To infer that, you have to do the text processing, and that's where the unstructured data, the processing of unstructured data becomes complex. Good point, Sam. Thank you. Okay, so another question from Kamal is, are logs come under unstructured data? Yes. All right. Brilliant. Good. All right. Now the traditional definition of big data. So the, these are the three characteristics of data. I'll just keep myself to only three V's because there are many V's included, and I'll just focus on the main definition of big data. All right, we'll not go into the veracity and the value part. Okay, so when we talk about the characteristics of big data, as in when we say big in terms of what? Is it in terms of the total amount which is to be stored, or the total amount that is flowing over the wire, or it is the complexity of the problem and complexity of the data? Okay, so overall the agenda is the characteristic of the data that pushes you to use multiple computers instead of one. The problem statement, the problem statement that says that, okay, you cannot use the problem statement leads to a situation that you cannot use a single computer, and eventually you have to use multiple computers. Okay, and what could be the scenario? First could be the data could have really high volume. To store such data, you cannot get it done through one computer. You cannot store such data using a single computer. You need to have more computers. And we'll see why it is that we cannot store such a huge data on a single computer, not only for the storage, but the rate at which we read from the disk becomes completely impossible if we are trying to use a single computer. So the volume part, which is called data at rest. So whenever you when you imagine this, the all the data Facebook is storing every day, the photos of the whole world, videos of the whole world, and the text which we are all the time posting. So everything is has to be stored at the end of day, right? It has to be stored somewhere. To store such a huge data, you need space. Okay, you need a place to put. So this is the volume characteristic of the data. Second is the velocity. The velocity part is, imagine how many people would be hitting the Facebook servers every second. Every second, their Facebook app is connecting to Facebook and automatically hitting Facebook and asking for updates. Similarly, all the people who are opening up the Facebook all the time, or they have opened on the desktop, they're actually sending requests to Facebook servers. So there are millions of requests that are going to Facebook every second. So this kind of volume cannot be handled by a single computer. All right, even if this traffic doesn't lead to any volume, imagine a situation that you are having this really powerful website. All it displays is a number. Okay, you are running a counter. It's a website which displays a counter on the website. It only has a single number. It shows that these many visitors. Now, even though the volume might be very small, it's just few numbers, right, which can be easily stored. But if there are so many people, so many users coming to your website, you would have to have multitude of computers to handle those many requests per second. Okay, a single computer cannot go beyond few thousand requests per second. Okay, it's very difficult to get it done using a single computer. All right, now the third part is the variety. The variety means, so I hope I'm clear when we comes to volume and velocity. Now moving to variety. Variety is an interesting point. So there are some problems in which even though there is no velocity involved, as in number of requests are not high, or the database is not high, and the volume is also not there, still the problem pushes you to use distributed computing. Okay, so when we say variety or complexity, it's not only about the data is very complex. It could be that the your requirement is complex. Let's take a case of finding the social graph. You have got some data. Let's just take a case of Google Maps. Google Maps has around, for a country or for a state, the Google Maps would be hardly 200 gigabytes data. For a state, it's hardly, for a city, it's hardly actually 200 MB, 200 gigabytes. So even with all the details, metadata, and all the uh, artifacts related to a city, it would hardly reach 200 gigabyte data. 200 is still an exaggerated figure. Okay, but storing 200 gigabyte data does not require many computers, does not require more than one computer. 200 gigabyte is comfortably stored on one computer. Now, when you have 200 gigabytes of maps, you have to find the location, find the direction from one place to another, find a path from one point to another. How would you do it? If you think about it, you will have to try out all possible ways from one point to another, and then compare all of those to figure out the best way. Although this approach is very crude, there are better approaches, but the overall tendency is similar, to find the way from one point to another. Now, no matter how no matter how optimized algorithm you write, you cannot get such kind of work done in reasonable time using a single computer. Okay, and that's where the complexity part comes into play. If your problem is complex, or your data is complex, if your data is complex, such as social graph and maps and a highly dense structured data like hierarchical data, and you have to figure out some information out of this, then your problem could be so complex that you cannot get it done using a single computer in a reasonable time. All right, in the similar fashion, if you have to say find out what is the relationship between all the species of the world, how is the hierarchy, given all the information about all the species, all you want to do is find out the closeness between one species to another. So you have to compare every species with every other, and then you have to draw the graph. So such kind of problems are really very complex, and effectively such kind of problems require more than one computer to solve. All right, so that was the three V's that describe big data. All right, now feel free to ask questions while I'm talking. Okay, so all right, now a question to all of you, although it's I know all of you know the answer to this one. How many bytes are there in petabytes? Yes. All right. So there are two problems I want to answer. There are two questions I want to answer. All right, and then we'll get into this question. All right. One is from Rohit. Question is, does that mean variety problems mainly occur on unstructured data? Not really. Okay. Not really. Okay. So when we say variety actually means the variety of data as well as variety of problems. Okay, so there are some problems. Let's think about recommendation engine. In case of recommendation engine, the input data is well formatted and structured. Okay, we will talk about recommendation engine. So there are many problems, even though the input data is well structured, but because the problem statement is really difficult, we require multitude of computer to solve such problems. So variety means variety of data and variety of problem, both. All right. There is a question. Is the limitation of one computer mostly the amount of independent cores thread that can be handled? Brilliant, Peter. And we have a next slide exactly for that. All right. After third, fourth slides. That's a very important point, and I would like to go into the detail. All right. So coming back to it, so almost everybody is correct. It's 10 to the power 15. Okay, Mauritius. So yes, the way you can remember is using terabyte. So a petabyte is 1024. A petabyte is 1024 terabyte. And a terabyte is 1024 gigabyte, and gigabyte is 1024 megabyte, and a megabyte is 1024 kilobyte, and a kilobyte is 1024 bytes. So this is what it is, 1,000 times the previous one. Yeah, it's around 1,000 times. Billion. So most of you have answered correctly. All right, great. Here is a bigger question that I wanted to ask you. So, a common question which lots of people ask is this big data or small data? Is that big data or small data? Here's a question to all of you, to me. So, we know what is big data now. Big data is something that requires multiple computers to handle, right? And we know how much is petabyte. Petabyte is 1024 terabytes, meaning having 15 zeros. Now, if you just have to count number of vowels every day in a petabyte data, can you do it using a single computer? Can you do it without distributed system? Okay. So is the problem statement clear to you? Okay. So let's say you have 1 petabyte data and all you want to do is you want to read the data every day from end to end and count number of vowels in this data, which means you will have to go through the whole data from end to end counting number of vowels, assuming every day the data is completely being modified in unpredictable ways. So so can you do it using a single computer? Yes. All right, I know some of you are doing calculations. Good, I'm really happy. And all right, so the answer by most of you is no. Okay, Sai says that you can, but it will take a lot of time. Okay, I will take it. I'll take your points. Okay, there are a few interesting. So Sai says that it will take a lot of time depending on algorithm. Okay, Dripu says that I think it's big data and needs distributed computing. Good. And Mehboob says that it's difficult to tackle and computer may hurt. All right. There is another point which I want to highlight here from Peter. If you have supercomputer with tons of cores, then perhaps. So from these 2 points, it is, I mean, we are talking about two things. One is algorithm, second is the processor. All right. If the data at rest, it won't be any problem. Uh, Yeah, so the data is actually at rest. Every day data is accumulated. All you need to do is read the data from left to right and keep reading it and counting the vowels. Okay, so here we can't improve the algorithm much. Okay, and my question is, do you think the processor is going to matter much? What is going to be the limitation? All right, I think we have got the right answer. It all also depends on disk speed. Yes. All right. Let me answer this and then yes. Okay, Murkesh is also saying the reading of the data might take a lot of time. Brilliant. Brilliant. So the general answer is yes. A petabyte data is actually big data, not only for processing it, but also to store it. To store it is actually a difficult problem. 1 petabyte data requires 1000 disks of 1 terabyte each. Okay. Now, here's the question I want to ask all of you. How much time does it take to read 1 terabyte from a hard disk? Anyone? Okay. Murkesh says that it depends on the reading rate. Yes. Take the safe assumption and give me a rough estimate. An error of 2x or 3x is acceptable. Okay. Mahbub says 15 minutes. Harita says 12 hours. Anand says 45 minutes. Okay, okay. Rohit says it's around 7 to 10 hours. Alright. Kamal says 30 minutes. Alright. Dilsad says 4 to 7 hours. Alright, alright. Alright. Those who said above 5 hours are actually correct. Even 4 to 7 answers is right, and even 7 to 10 hours is right. Harita's answer of 12 hours is also correct. Okay, so basically there is a slight variance of number of days, I mean number of hours, but that's okay. So the way hard disk works is there is a header and there is a rotating speed of the disk. So the disks have different rotating speeds, and because of which different disks have different reading speeds. You can only read as fast as the disk can rotate, right? And therefore you are limited by the physical speed of the disk. Okay, so in 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 a best case scenario you will get around 6 hours. You can read 1 terabyte of data in 6 hours. Okay, so even if you are just reading the data and discarding, you're just reading the data and discarding the data, right? Still it will take 6 hours. No matter which processor do you use, you will still it will still take 6 hours to read 1 terabyte from hard disk. Now, this is not good because 6 hours is quite big time. If you think about 1 petabyte data, it will take 6,000 hours to read 1 petabyte data from the disk. If we are using solid state hard drive, the speed might be 10 times. But still, reading 1 petabyte data, even from solid state drives, will be will take around 600 hours. From hard disk, it will take 6,000 hours. Now, do you think that 1 petabyte is a big data? Peter? Great. Great. So the important part which we learned is not the algorithm here, although algorithm makes a lot of difference. So here it's not the algorithm, neither it's the neither it's our processor. It's the reading speed. And when we talk about these characteristics, I'll just try to map the characteristics. Okay, maybe after 2 slides. All right. Next is that why big data now? Why do we want to process that amount of data? The reason is data has exploded. The total amount of data that's being generated around the world has started increasing exponentially since 2002. Okay, and why did that happen? The simple answer is connectivity and the devices. devices and the connectivity. While on one hand the devices became cheaper, faster and smaller, on other hand the connectivity became available in many forms and really faster. You have 3G, 4G, 2G, and you have these network connections everywhere. Also, you have the so basically you have these connectivities all the time. As of today, you have Wi-Fi, you have Bluetooth, you have NFC, you have other radio waves. So the connectivity between devices and between people in the form of social network has become more and more permanent. So while on one hand devices are generating a lot of data, and connectivity is basically multiplying the data. All right, here is the question for all of you. So which components impact the speed of computing? Anyone? Brilliant, brilliant. Harita, I think you typed by mistake. All right. Yes. So all of you have answered as all of the above. So I mean, although it sounds very unreasonable at the first, because whenever we think about computer or computing, we always think about the microcontroller, which is the processor. Okay, we always have been obsessed with having faster CPU. But trust me, the CPU in your machine is the most free device on the servers. Okay, if you monitor your servers, you will notice that your servers are hardly consumed. In the worst case scenario, they are hardly consumed 30%. So if a program is consuming 100% CPU on a slower computer, it will still consume 100% CPU on the faster one. Okay, so CPU, if CPU is being the bottleneck, it's your algorithm mostly which is making it bottleneck. Okay, second is the memory. Okay, so second is the memory, and when we talk about memory, it is read and write speed both. And when those who are not aware about what exactly CPU does, so basically CPU reads the instructions and execute them one at a time if they are and make sure execute the instruction could be change this data from the increase this data by one, or the instruction could be jump to any other instruction. Okay, so that's what CPU does. So the faster the faster CPU reads the data, the faster it will be able to perform. Okay, so generally CPUs are really fast, as in when we say 2 2 gigahertz processor, it means it takes an action, it takes 2 billion action per second, roughly. All right, it takes roughly 2 billion actions per second. So CPUs are fairly fast. Second is the RAM, which is speed and the size. So Actually, RAM is the one which becomes the bottleneck immediately. Okay, even though your RAM might be of 100 gigabyte on servers, still it gets full very quickly. So other aspect of when you think about RAM is random access memory, and whenever we do any processing, we generally put most of the data into RAM and then process it, and the CPU reads from the RAM continuously. Now, the other aspect to think about RAM is s- other than size is the reading speed. So I saw lots of people using multiple virtual machines on a single core or a single computer, thinking that suddenly they'll get more processing power. No, the read speed of the RAM is fixed. All right. Therefore, the RAM can also be one of the bottlenecks. The third is the disk, and and when the volume grows big and big, it is the disk which becomes the bottleneck. Okay, it is the disk which becomes the bottleneck. The disk in terms of speed and the storage. Although there has been a most of the disks are being replaced by solid state hard drives, which are faster and more reliable, but still the disk will still be a problem. In case of solid state hard drives, it is the size which is the bottleneck. Okay, it is the size which is the bottleneck, because most of these solid state drives are smaller and are far more costlier. Fourth is the network. Network is something which most of us do not think as part of the computing engine. Why? Why is network? Why does network impacts our processing? Imagine this. Let's say you are not able to store your data on the disk. You will push the data to a remotely available computer. Or your RAM is not sufficient, so you thought that you will utilize a distributed cache. Okay, you will use something like memcache on your servers so that all your computers will read data from a central system. Okay, and that's where the network becomes the bottleneck. All right, so network actually plays the role really in a very big manner. So we cannot ignore network when we think about processing and storing data. All right. So there are these four components. All these four components matter a lot when we do the computing. And when we are talking about big data, any of these four components will become the bottleneck. Okay? Any of these four components will become the bottleneck when we try to process big data. Okay, keep this in mind. If none of these four components are becoming the bottleneck, then you don't need big data systems. If you're happy, your none of these four components are bottleneck for you, then you are pretty happy. You don't need a big data system. You don't need a big data system. Maybe you realize that okay, your RAM is becoming the bottleneck, and all you did was you started using disk, and now you are able to solve your problem happily. Then you don't need the big data solution. All right. So there is a fluctuation. Any questions at this point of time? Yeah. Hi, can you hear me? Hi, can you hear me clearly? All right. So yes, I'm here. So I had a momentary disconnection because of the power went off. So from my ISP, there is some problem. All right. Okay. So are you able to hear me now? All of you? Are you all right? Are you able to hear me now? Hello. Great. Great. So everybody can hear me now. All right. All right. So before the connectivity went off, we were discussing about how various components can become the bottleneck. All right. Now coming back to the other reasoning behind big data. So yeah, we talked about various things. We talked about why big data is growing big. We also talked about why what exactly is reasoning behind becoming the single computer becoming the bottleneck. We also discussed about the sizes of data and the complexities. So now the question is, what is it that it brings to the table? We have data, we have big data, and we have great solutions, but what is the point? Why do we need to process such kind of data? The simple answer is, using the bigger data, you can always compute the better results. Okay, think about computing average value of something. Okay, the more the numbers you have, the better will be the accuracy of your results. Okay, so that is the probably the most simple words. It's called law of large numbers, because the larger numbers you have, the better results you will have. Okay, now where does these kind of problems make sense most? Although big data actually touches all aspects of the computing. Okay, here are few of the important ones where the world started seeing the importance of big data. The first is recommendation engine. Now we'll go to recommendation engine and come back. So recommendation engine is where you want to recommend something. Probably every one of us does it all the time to their friends, to themselves, and to their family when they keep on recommending things, or they keep on looking out for recommendations for themselves, as in what will suit me. Now, if an advertisement is very closer to what you need, then you don't consider that as advertisement. Okay, so that is the magic of being relevant. Okay, that's the magic of relevant. If something is very relevant to you, it's no longer an advertisement. All right, and that is the reason why Amazon probably makes lot of sales due to great recommendations. Okay, so after emails, Amazon makes most of its sales because of recommendations. So the better the recommendations are, the better sales you will get. Okay, so and the better recommendation you will get if you have bigger information about the users. Now look at this Netflix suggestions. They will be great only if they have lots of information about lots of users. If I know that there are so many people liking this particular movie, and similar people also like some other movie, now I can draw conclusions. So when you think about recommendation, it's actually very interesting idea. So so imagine this. So we have the information about all the people, and we also know that these people like these movies this much. Now, if we can group them together into clusters based on similarity, based on how much similar they are to each other, then we will be able to cross recommend one's movie to another. So if I am very similar to say, if the movies I liked are very similar to Shashi's movies, okay, which means me and Shashi are similar in behavior. So the extra movies which I have watched, and I have liked extra movies, those extra movies which Shashi has not yet, we can recommend those movies to Shashi. And similarly, the movies which I have not watched but Shashi has watched and liked those, I could be given that as recommendation, and that's how the recommendation engine works. Now, by now, you must have realized the more the information we have about the users, the better it is going to be. Okay, now, so we established that the more the information we have, the better will be recommendation, and the better will be the user experience, or the better will be the sales of your movies. Okay, therefore building such kind of recommendation is very important. But recommendation is a complex problem, and it requires a lot of computing, lot of storage, and because it lies in the complexity domain, I mean the variety domain, because here the the processor RAM might become the bottleneck along with the actual data that needs to be processed. The one I did at InMobi required around 200 gigabyte of data cleaning. So they had the raw data that needed to be cleaned. For that, we built all kind of systems, and that was definitely not possible using any single solution. A computing platform like R, or the systems which only worked on a single computer, could not solve those kind of problems. All right. So a recommendation might be very simple. You see, this is a three-column data. First containing user ID, second movie ID, third ratings. Meaning Kumar likes Matrix this much. And Kumar also likes I says this much. Giri likes Casablanca this much, and so on. Now, the systems like Mahat, although there are newer systems to replace Mahat, but the philosophy remains same. So systems like Mahat will take input in this form and immediately generate the recommendations like this. It says Kumar would like Apocalypse Now this much. Now, so generating recommendations has become such a easy phenomena. All you need to do is prepare data in this form. It'll give you the result. All right, and that's how most of the recommendation engines work. Second problem that requires solving is sentiment analysis. Also, these problems benefit from big data. If you have bigger set of statistics, the result will be better rather than the smaller set of statistics. Now, Now, the overall idea about sentiment analysis is finding out whether you are doing good, your brand is doing good, or it's going down. Okay, so whether your upcoming product has got positive reviews, or the product you've recently launched has got positive reviews or negative. The time is gone when you used to conduct surveys in the world. So earlier the strategies were little different. You used to send people to conduct studies, and once you have conducted studies, you will try to analyze. You will sample the audience and you will try to extrapolate based on the samples. But today's those techniques are not that successful because of data gathering techniques have biases and other phenomena, and those are very costly and time consuming. Therefore, a simple sentiment analysis, such as understanding the behavior of customer from Facebook and Twitter, is good enough insights for all the people. Okay, just that you need to get all the information. So the bigger the data in case of sentiment analysis, the better response, the better results you will get. All right. Now, other than sentiment analysis and recommendation engine, there are there are many use cases which benefit from big data. Imagine the search quality. In search quality, there are many aspects in which the searching happens. So when we take stock about searching, searching could be you building a search engine, or or you're building a small application which requires searching. Even though your data may not be that big, but you may want to provide a great auto completion. When people type something, you would like to give an auto completion, or you would like to give your users an autocorrect. So to autocorrect or auto completion, you will have to prepare a great dictionary. And to prepare a great dictionary, you need to do a lot of big data stuff. Okay, as well as the search quality, as in to figure out how much time a user is staying on a page, or how many links they are visiting, is very important. Then in e-commerce domain, there is something called A/B testing. It is important to know what is A/B testing. All right. So at Amazon, we used A/B testing exhaustively to a very large extent to weigh how is our feature doing. Okay. Let me take a step back and try to take a case scenario and then explain. Now, let's imagine this. You are working at a company like Amazon, and you realize that buy now button, the button with which you purchase something, the buy now button has to be changed to blue from green. Okay. Now you come up with this idea. Let's change the buy now from blue to blue, and you have this gut instinct. But how would you convince people? How would how would you yourself be sure that it would work without making failures? So that's where the A/B analytics comes into place. So what we do generally is we launch a new idea or a new modification to only a small set of users. A small set of users, as in 1% users or 2% users. And for Amazon, 1% users is really high. And then if it is doing good, we compare this 1% sample with some other 1% sample, and then compare which one is doing better, the green one or blue one, where which one is easier to find or spot for the end users. Okay, and that will lead to our sales. So we will do this computation using A/B analytics. Now, when you have A/B analytics, A/B testing or A/B analytics, you always have so many systems using your A/B analytics. And also, A/B analytics only makes sense if you really have good enough users. When I say let's run it over 1% users, it doesn't mean we are running it on 2 users. 1% is still thousands of users. 1% for Amazon is still 1,000 users. So if you don't have enough users, A/B testing would not make sense to you. Because if you have just 500, 600 users and you are trying to figure out based on analytics, it will be very, very difficult. You might get, you will get many kind of noise. All right. So, so A/B testing makes sense on big data, as well as A/B testing generates a lot of data and also requires tremendous processing. Therefore, A/B testing is a good recipe for big data processing, and it's being used by almost every giant. I know about Google and Amazon. For rest, they must be working on that. Okay. Now, telecommunication, like in telecommunications, they can stop their customers leaving that if they figure out by analyzing the customer records. Now, I mean, this is being done by many companies already. Also, the network performance optimization is another use case. All right. Third is the calling data record analysis and then analyzing network to predict failure. Okay, so when we talk about telecommunications, even a very simple thing is big data problem. All right, I'll give you a very small example. So there was a Saudi Arabian companies who we worked for as one of our students' real life project. So the idea was the problem they were facing was that they could not compare the configuration changes of all the equipments. So every tower has got many equipments with it, and all these equipments are being configured, reconfigured by many technicians. So all we wanted to do is track the history of all the equipments and see what led to the failure. And just doing this simple comparison was really, really difficult. Really, really difficult. When I looked at the data, it went into terabytes, okay, just for few of the towers. So basically anything you do on telecom is actually going to spiral into big data problem. Rohit's question is there any tool for sentiment analysis like Mahad? Yes, there are. There are tools which will help you, and one of the problems which we will take up, we will go through the sentiment analysis and we build the sentiment analysis from end to end. Since there's a lot of customization requirement when the way we define sentiment, therefore, out of the box, any solution out of the box will not make anyone happy. Although there are websites which help you track the trends of various products. Okay. All right. The other big data customers are government. Government can use and some of the governments are already using big data for fraud detection, cyber security welfare, and for justice. Justice as in figuring out laws and tracking each and everything. So there's a huge requirement of the computing tools which can work on humongous data. Healthcare and life sciences. Okay, so health information exchange, gene sequencing, healthcare improvement and drug safety are few of the requirements, few of the things which in which healthcare and life sciences is very important. So anything in healthcare, just like in telecom, anything, even the smallest problem, actually becomes a big data problem. Reason being the information which is gathered during healthcare is actually tremendous. Most of the statistics, most of the data sciences has been has been has come from the healthcare section. Lots of data science, including A/B testing, the one which we discussed. A/B testing is actually a concept that came from healthcare. Okay, so so in healthcare and most of the computing, if you remember, the supercomputers and everything was first used in healthcare. Kamal's question is, sir, tell me more about telecommunications use in big data. So in telecom, anything which basically accumulates data about various stations, various towers, various equipments will lead to a big data problem. Even the accounting, even the tracking of call records is a big data problem. All right. So there are many use cases in case of telecom industry because they by default are sitting on big data. All right. So there are many use cases actually, starting from customer churn prevention, network performance optimization, calling data record analysis, and analyzing network to predict failure, even as simple as tracking the changes of the configuration file of all the network equipments to detect the reason behind a failure is a big data problem. All right. There is a question from Anand. Question is, if the processing which is required should be sequential, then is big data solution helpful? All right. So yes and no. All right. It's a difficult, very difficult question to answer. So there are some problems which need to be solved in a sequential manner by a single computer. Okay. Such problems generally cannot be distributed and cannot be converted into big data problems. But as a developer, as a algorithm designer, or as a product manager, everyone's tendency is to break a problem into distributable. For example, do not write for loops because for loops are not divisible into cannot be sent to multiple computers. Okay, so basically the tendency is to convert a problem in so that it can be executed on multiple machines, and that is the reason why most of the algorithms are rewritten in order to get it done using multiple computers. So probably this is probably one question, okay, which would answer the fact that most of the systems are being rewritten, and most of the there is a huge demand in industry. Reason being, the systems by default, the way they are designed to run on a single computer, cannot really divide the work onto multiple machines. Therefore, most of the systems are being migrated, most of the systems are being created. I hope I have answered your question. All right. Was I able to answer your question, Anand? All right. Great. Let's take a break of 10 minutes and I'll just write in IST. We will be back by 8:41 a.m. Hi everyone, I'm back. Should we start now? All right, all right, all right. So, great. Do you have any questions at this point? All right, no questions. Hi Mehboob, we can take it offline. No worries. We can talk over. I can schedule a call and we can talk over. All right, no worries. All right. It'll be difficult to discuss the things here. All right. Just drop an email to reach us at No Big Data with your phone number, and I'll give you a call. All right. I'm talking to Mahbub. All right. Great. So, all right. Should we start, or do you have any questions as of now? All right. So there are few more myths. There are common myths which go around big data. One is it always means the data has to be beyond terabytes. Not really. As I gave you an example of recommendation engine or an example of categorization or classification of various species, those problems, even though the data may be smaller, will actually grow. The computing becomes complex and would require multitude of computers. Okay, so beyond and above the range of terabyte only matter if your problem is volume related problem, not variety related problem or velocity related problem. Okay, next is big data is always about social media and doesn't apply to me. So the only use case, the one use case which is very popular about social media is the sentiment analysis. That's why people get an impression that big data is only related to the uh, social media. No, big data is probably applicable in almost all the domains. As of now, say for example, the project I was talking about, we are working with Dell. We are tracking the behavior of each and every order. When you place an order with Dell, in what all states it's going through, what all detail, what how much time every step is taking, and we are keeping this data for the future analysis. And to do that, we required big data solution. They required big data solution, and that's where they approached us. Now, so next is, will replace enterprise data warehousing. The answer is no. It will not. It will not completely replace EDW, but it will replace the cases where we want to do the computing and we don't have transactional requirements. If we don't have transactional requirements, then most of the information can be moved to big data, provided the data is good enough or big enough to be processed on big data systems. Next is, it's just a buzzword, no practical application. So, I mean, by now, the big data has proved itself to be the real thing rather than just a buzzword. Okay, When we talked about Web 2.0, this, that, okay, it's not like normal keywords because most of the buzzwords die out in a year. There are real implications, there are real applications. I have worked on those since quite some time, and I've seen the companies benefiting because of the data issues. It is completely inevitable to move to big data infrastructure. It's a new concept. No, as I explained to you that when I worked at DE shop, we had 10,000 nodes cluster. That means these concepts have been there since 2000s. Just that the applications are really, really great in today's time. We have systems which are really powerful and work on distributed computing, and all of them in open source. That is new. Earlier, though there were all of this was very, very secret sauce. It was very secret science where companies will keep everything very hush. For example, we were not allowed to talk about our cluster at all to anybody in 2000s. Okay, it's only in 2005 New York Times did a story on us on the show, and that's when we it became okay to talk about it because anyway became public. All right, and so it's not a new concept. It will be the future. No, it's the present. It's expensive. No, it's basically opposite of expensive. So most of the systems they are designed, most of the distributed computing is all about having having to use multiple computers, and therefore it's always favorable to have more computers than a very big computer. Instead of buying a very big computers, it's always suggested to have more computers. And we talked about four things: CPU, RAM, disk, and network. All of these four things double because network card also doubles when you buy two computers, right? So your network read speed has doubled, your disk IO has doubled, disk size has doubled, RAM has doubled, and CPU has doubled. So an ability for CPU to read from RAM has also doubled. So effectively, if you buy two computers and are able to divide your problems so that both the computers could be utilized really, really well, then buying two computers is better than buying one. Okay? Buying two computers in 1 lakh each, 1 lakh as in 1 lakh each is better than buying a single computer for for the same amount, for 2 lakh rupees. Even though the specs are double, still don't buy a single computer, specifically for data intensive jobs. All right. Next is that it's only for data scientists or is magic. As I just showed you in the previous slides, that tools like Mahat has become really, really easy to use and everybody can use those. Okay. Therefore, they are not only for data scientists. Whatever data scientists do, whatever algorithm they build, it's all is actually available as a commodity in the open source world. And that is the beauty of the era we are living in. Almost every great thing is available as open source. The most the most complex thing that was considered earlier was voice recognition or the character recognition, and all of these libraries are available for free in open source. So these things, whatever data scientists or whatever researchers are working on, it's actually made available to you as open source, and therefore you do not have an excuse to say no to the complex problems because algorithms are already available. Next is we have enough hardware, don't need anymore. These are very common excuse because the psychology which people have developed over a period of time, that anything to do with new database or new computing would eventually lead to purchasing of hardware. But in case of big data, that's not the case. You can utilize the existing hardware in a really, really robust fashion. You do not have to buy a new hardware. For example, to run your Hadoop systems, you hardly require 8 GB RAM. Okay, you hardly require 8 GB RAM, although it can very well run on a 2 GB RAM system as well. So effectively, you don't have to acquire new hardware. We will build it when we need it. Okay, this is another thing which I see as very big myth. So the problem with this kind of psyche is this kind of mindset is that that when you need it, you will not have it, because for having some sort of insights you need to accumulate data, and to accumulate data you need to build it now. Otherwise, by the time you realize that, oh, you need to do this kind of analysis, you have already lost so much of data. You did not store data, and therefore you will have no insights. So it's not an immediate thing that, okay, today we want insights into the our customers. Why are our customers leaving us? So let's build big data system, and big data system will tell you immediately. No, you have to plan, and you have to gather the data, and you have to build the full architecture in order to take the full advantage of the big data scenarios. Next is that big data is about Hadoop. No, there are many solutions available in big data. For example, let's take a look at these solutions which are available. Big data solutions which are available as of now are Apache Hadoop. So out of all the stacks, probably Hadoop combined with Spark is the most viable solution. And in my personal opinion, that is a great place. In case you are only looking, you are okay with exposing your data to the third party, then it's going with Amazon AWS or with Hadoop on it is also good, or going with the Google Compute Engine is also good, and you MongoDB and Cassandra stack is also good in case you don't require too much of computing or too much of unstructured data. Okay, so there are many big data stacks available, and out of those we prefer Hadoop along with the Spark stack. And as part of this course you will get to learn each and everything related to Hadoop, and you will also learn how to use Spark and where does Spark fit in. Now, so those topics which are not the core topics, we will just show you one hands-on exercise on all of those, say scoop, flume and all. While those concepts which are really important, we will dedicate full sessions to them. All right. So that was a little bit about. There are many big data solutions. I've just counted a very few. I've just counted three, four stacks. All right. Now let's. There was one more thing which I wanted to show you. With respect to salary trend, this is a common question which I ask. I would strongly recommend everybody to do your own research on the websites like Indeed.com if you are looking to understand which technology suits you as part of your career. Okay, so as of even as of today, the trend at Indeed.com with respect to technologies is that Hadoop is being still the highest paying job. All right, Hadoop is still the highest paying job amongst other technology stacks. All right, great. Anand, Carlos, Dilshad, Deepu. And is everyone with me? All right. A question from Peter is that will this course give enough knowledge in Hadoop to potentially acquire a job afterwards? Yes. Yes. It's a course geared towards very hands-on exercises which will actually boost your confidence that yeah, I know Hadoop and this is how things happen. Okay, but for that to happen, you have to work with me from beginning till end, solving the problems which we are solving. All right, and once you it not only boosts your confidence but also gives you a practical applications which during your interview will be of tremendous help. All right. So Rohit's question is there any big data use case in insurance domain? Yes. In case of insurance, figuring out the how much insurance can a person be uh, uh, covered with is a very big data problem. All right. If so, there are many use cases such as if you know about all the people who failed providing the, I mean in so how can you let me take a step back and explain again. So let's take a case that say there is a person and you have to predict what kind of insurance we can provide them at what price. Okay, so first you will have to find out the similar users like him and in past what kind of insurance has worked well for them or what kind of insurance they was a big loss to your firm which is providing the insurance. So if you know that clearly about the past, you can predict the insurance, how much insurance can you give as a coverage. So those are the problem statement which almost everybody seems to be working on. All right, there are many use cases in the insurance domain. Does it make sense to you, Rohit? All right, Peter, was I able to answer your question? All right. Now there's a question from Harita. Thank you for asking this question. Do you cover real-time processing layer in Hadoop using Kafka and Spark streaming? Also, do we have any hands-on on lab on that? Yes. So I'll do it in parts. I'll do it in parts. So yes. And yes. Okay, so this was started because in the last session itself, the session which had just finished recently. So that time we realized that it is important for the candidate to see for life how the Kafka and Spark work. All right, and we will give you a hands-on demo on Kafka and Spark streaming, just and show you how it's able to handle around 100,000 packets per second over the cluster. Okay, right now let me check if it's up or not. I doubt it will be up. No, it's not up. So basically, we give a just exhaustive example of both. And so as part of this, what we are doing is we are shrinking the non-important topics a little bit and increasing this. And because of including these kind of topics, there are chances that this course might become a 12 session course instead of 11 session course. All right, so be aware about that. If you have some other plans of after this course, so please postpone those, because postpone them by 1 week. Okay, so it might go up to 12 sessions. So I wanted to update the course page. We will probably update it now. Okay. So because it seems to be really, really big course. All right. And the reason why it's big is because of these reasons. Okay. So now is the time that we start with the few things. All right. Dirpu's question is Java knowledge prerequisites for this course? No, but it is better. Okay, so we provide free Java course which you can right away register and start learning. Okay, so in one of the sessions, session number 5, you would need Java, because that session is dedicated to Java with MapReduce. Okay, MapReduce with Java, and therefore you would require knowledge of Java, and that's why I lots of students were asking for Java, so we I gave a free session to all the students and recorded it, and that became our Java pre-recorded session. Okay, so you can go through that. So yeah, question from Pankaj is, which component of Hadoop need Java? Mainly MapReduce, but MapReduce can also work with other languages, and we will talk about those languages as well. Okay, so let me go through this one, and as we go, you will know what to. I'll answer this question again. Okay, I'll answer this question, these two questions again. All right. I think that will make more sense to answer those questions again. All right. So a long time ago, as in 2008, probably 2007, a person called Dog Cutting and was working on his personal project called Notch, which was essentially a search engine. Okay, so they were building a search engine, and that time they realized that the Google file system, sorry, okay, so they were building a search engine like Google, and they were trying really hard, but they got stuck with a point that they could not go beyond. They realized that the file systems, the compute engines, the way we do the computation, all of those things are not really great yet, and they were stuck there. There was a deadlock. They could not figure. They were trying to solve their problem storage, which was not possible using any of the systems. The kind of web scale data they needed to store. And lucky for them that Google published those 3 papers: Google File System, Google MapReduce, and Google Bigtable. And that became the basis for them for moving ahead. So what they did was they implemented those papers, and that became Hadoop. Not search engine. I'm not sure if that got released ever, but Hadoop became really, really useful. So so they basically made it open source and made it with Apache license, which means anybody in the world can use Hadoop for any of the uses, be it be it personal, be it academic, be it for hobby, be it for professional, be it for selling the product. Meaning you have built something and you have bundled it on Hadoop and you are selling it with it. Still, Apache license will be perfectly okay. So Apache license is really very liberal license, and thereby it gives a big peace of mind to all the developers like myself to work with them. The reason I am today giving a session on Hadoop is because Hadoop is open source. Had it been like Microsoft some XYZ component, I would have to seek I would have to seek the licensing from Microsoft. And Microsoft has its own rules, and I'll have to abide by them instead of being more focused on experience. I'll be more focused on the license, and therefore such kind of components cannot scale without having an open license. Now, because of they built the components parallel to Google file system, Google MapReduce, and Google Bigtable. And the one which is parallel to Google file system is HDFS, Hadoop distributed file system. Google MapReduce is Hadoop MapReduce, and google bigtable is Google Bigtable is HBase. All right, Google Bigtable is HBase. Now coming back to the point. So the whole idea about Hadoop, as it became an independent project itself, was to promote the large scale computing. A computing which is reliable, scalable, and distributed. Meaning, reliable means if one computer fails or something fails, still the work gets done. Second, it is scalable, meaning today I am doing some computing for few gigabyte. Tomorrow, when gigabyte becomes terabyte, it should not I should not keep on changing the framework. Third, distributed, meaning utilizing so many computers usually utilizing so many computers to do the computing. These were the premise of Hadoop. So all the components that lie in the umbrella of Hadoop are reliable, scalable, and distributed. And effectively, it's a framework to handle big data because those are exactly the definition of any big data tool. All right, it has to be reliable, scalable, and distributed. It was named Hadoop was named after the toy elephant with which dog cutting son was playing, and it is written in Java so that they could run Hadoop on almost every ecosystem. And that is the reason why today HD Insights, which is Hadoop on Windows, is possible. Okay, so because it was written in Java, it became possible to run it on almost every architecture, hardware architecture. Now, it doesn't mean that you can only interact with Hadoop using Java. No, you can interact with Hadoop using many languages, as we will see that later. All right, now let me get into, we have 50 minutes. All right, we have 50 minutes now, and we will go into the full ecosystem of Hadoop. All right, we'll go into the full ecosystem of Hadoop. If you have any questions at any point of time, feel free to ask. All right, this is little intensive, so yeah. All right, so the base or the root of the game is Hadoop distributed file system. Hadoop distributed file system, you can see the blue one here, this one. This is Hadoop distributed file system. Now, what does this file system do? It helps you store humongous data without creating a complexity for you. It's a single file system which is running on many computers parallelly. We will cover HDFS in real details in the second session, but we'll just give an overview here. So in Hadoop distributed file system, you have multiple nodes which are connected together, and you store data on all of these computers. If one computer goes down, your file system remains intact. It doesn't impact at all. All right. So Hadoop distributed file system is the baseline for the whole ecosystem. All right. The way you have C colon, you have D colon in your computer, meaning the hard disk in your computer. Similarly, and in your similarly you have HDFS, and in the hard disk of your computer, your databases store their data files, right? If you have used MS SQL and all of MySQL stores each table separately in the file system, while MS SQL stores the whole database as a single file. Now, these files are stored where? They are stored in local file system, right? Similarly, in case of Hadoop, every other component will store their files in HDFS. Okay? Now, you will also store your data on HDFS. Now, once you have stored your data on HDFS, you would like to do some computation. Such as your computation could be you want to filter this data, you want to clean this data, you want to remove some record from this data, or you could do some advanced predictions like recommendations on top of this data. Right? Now, to do that, you require a computational engine which can run your logic on multitude of computers using the files stored on HDFS. Now that kind of computation can be done using yarn. That's where the yarn comes into play. Now on top of, so we have yarn. Yarn you can think of as if it's like an operating system to which you give your program, and this operating system will execute it. The only difference with yarn is it executes your program. It executes your program on multiple computers simultaneously. Now, this yarn is a very generic system. You will have to write program in some way so that it can be distributed, it can be divided on the whole cluster. And to do that, you will have to write you have to write either your MapReduce job or your Spark job. MapReduce is a component which basically takes the logic from you, takes the code from you, and executes it on yarn. Okay? It executes your logic in the form of map reduces. We will go into what is map and what is reduces later. So you write two functions called map and reduce, and you hand it over to map reduce. And internally, the map reduce framework uses yarn and the HDFS to get the work done. Now, at the same time, you have another framework called Spark. Spark is faster than MapReduce, has come recently, and Spark also utilizes Yarn to execute the code. Now, a general question here is, then how do you talk to MapReduce? So you talk to MapReduce by expressing your logic, by expressing your algorithm, by expressing your flowchart in in Java, in in Python, or in we use Java, Python, or any other language in case of MapReduce. Similarly, for Spark, you can get your work done in almost every language. So you express your logic in any language and hand it over to MapReduce. MapReduce gets the work done using yarn. Similarly, you express your logic in Python, Scala, or any other, and hand it over to Spark. And Spark gets it done over the cluster by using yarn. All right. So yarn is like an operating system being used by any program running. Okay. Now, next is that there is something called HBase. HBase is the NoSQL data storage. While on HDFS, the file system, you could store the data in terms of files. You created file, you dump the data, and that's it. Okay? There are no records. It doesn't have a record. If you have to delete one particular line from the file, you have to create a fresh files and copy everything except for that particular line. So modifying the data record wise is very, very difficult in the file system. Okay. All right. Murugesh is not able to see the slide. Could you just try to reconnect, please? All right. Now here you have HBase. When you want to modify the data record wise, if there is a lot of change that is going to happen with the past records, as well as you want to keep editing, then you use a database. The way in a database you have tables, you edit the rows and you save the data. Similarly, in HBase you have tables and rows and little bit more concept. We will go into the details of HBase. We will try to do a data modeling for a couple of problems because the paradigm of modeling had changed when it comes to HBase. Okay, HBase can store billions of rows. HBase is actually good only if you have billions of rows and millions of columns. Okay, otherwise your usual database like MySQL is great. MySQL is good enough for the smaller data. Now, we talked about a file system, a unified file system which runs using multiple computers, utilizing everybody's hard disk to store the files. Okay, on top of it, you have the compute engine running here called Yarn. Then, on top of Yarn, we talked about MapReduce in Spark, which calls Yarn to get the work done. Similarly, you can write your own thing, your own program, which can utilize Yarn. Okay, now on top of this structure, you have Hive, Pig Latin and Hive are really, really useful tools for those who are working on data oriented problems. Okay, so as we just discussed that to do various kinds of computation you can use MapReduce. So you might be wondering that for every kind of processing, whether I'm selecting few records or we are just doing group by or those kind of things, do we have to keep coding all the time? Answer is no. You can express logic in Hive, and Hive will internally call MapReduce to basically call. Hive will take SQL from you, convert that SQL into MapReduce, and call the MapReduce framework and get the work done and give the response to you back. So Hive is really useful for the problems which are very data oriented. Also, Hive is quite useful when it uh, comes to using the system in SQL. Second is the Pig Latin. Pig Latin is similar to our traditional SQL, just that it is far more simplified. It is far more simplified, and both Hive and Pig both are good for semi-structured. For structured data. So Hive and Pig are both good for structured data, while Pig has been designed bottom up to take care of unstructured data as well. So you can do good amount of ETL, ETS as in extract, transform, and load kind of work using Pig, as well as most of the data sciences work actually gets done using Pig. So you have Hive, you have Pig Latin, and you have Mahot. All right. Now, what does Mahout do? Mahout is not like a language, or Mahout is not like a big platform. Mahout is more like a library. A platform is something which runs somebody else's code. Okay, a framework is something like you have to code against a framework, but in case of Mahout, it is just a library. You use Mahout, you ask Mahout to compute various kinds of recommendations, various kinds of clustering, and Mahout will eventually hand it over the work to MapReduce and get it done. So Mahat is good for machine learning, meaning all the libraries related to machine learning are available as part of Mahat. Now, okay. Now there are few questions. Let me take few questions and then we will complete rest of the things. There's a question from Ravi Teja. In a distributed computing environment, where is HDFS placed? So HDFS is a little tricky thing. It looks like to you the facade, as in the outlook is okay. This is a great file system. It has folders inside file folders. You have files and so on. But beneath that, HDFS is actually broken down onto multiple computers, and every file is broken down into pieces, some pieces on one computer, some pieces on another, and some pieces on some other computer, and that is how HDFS works. All right, so HDFS is placed on all the nodes in the cluster. There's a question from Dirpu. Dirpu question is, so Spark is an alternative to MapReduce. Does that mean we have to use either MapReduce or Spark for updating our logic, or use both? My simple take is use both. Reason being, the problems which do not the problems which do not require real-time response, they are better off with MapReduce. The problems which require real-time response are better with Spark. Okay, because Spark utilizes RAM to get the results really fast, and sometimes RAM is far more costlier affair than you think, and therefore Spark can only be used in the scenario where you have good amount of RAM available. Okay, good amount of memory available. In case in case RAM is not available, it doesn't perform great. But our MapReduce has been designed bottom up to take the advantage of the disk, okay, but and very small RAM. And therefore MapReduce is good when we are okay with our processing being being we are okay with our processing being batch wise, okay, rather than instead of instant. So Pankaj's question is, can we compare Hive and Pig with existing language? The answer is SQL. You can say that Pig and Hive are basically, Hive is actually ditto SQL. Pig is a deviation, a little bit deviation from SQL. All right. There's a question from Anand. The question here is the data stored like physical files or stored as data blocks like Oracle? I'll say it's physical files. Okay? Don't worry, as we move ahead, you will learn that. So the data can also be saved in HBase like HDFS. Yes. In HBase, you have to save data in the form of the file system. Sorry, in HBase you have to store the data in the form of records. You have table and table has records. You keep on inserting either the columns or the rows. Next question from there is HDFS row based or columnar based file system? So it's a columnar. We will understand what is columnar. And I have seen that there's a huge misconception around columnar database. Okay, we will discuss all these things in detail. There's a good question from Peter. You mentioned that if one computer goes down in a distributed computing environment, it is okay. What is the level of redundancy typically? Level of redundancy is generally considered as 3. Alright? 3 meaning 2 computers are lost, still the systems are working fine. Okay. So Saroja's question is Mahat more like Becca? Yes, kind of. But Becca is yeah, Becca is in the similar bucket. Okay. Becca is like in a similar bucket. All right. There's a question from Pankaj. The question is, can you give some example of real-time response? Okay, real-time response is, let us say that you are trying to monitor the the current status of orders in your organization. You want to monitor those, and and therefore you need to build a system which continuously gets the data from the server and get displayed here. There is no wait time involved. Okay, mostly the real-time response systems are designed around queues. There is a data input from one side and there is a data output on another side. Okay, I hope I'm able to explain, Pankaj. Now, question from Murukesh is real-time example when we go for HBase. All right, all right. Let's say you are building a system in which you are trying to store the customer records, and from time to time you keep on updating the customer records as well. And these customer records are billions in numbers. Okay, the user's detail you keep on updating all the time, keep on gathering the data all the time, various attributes, and and you want to do it on a very large scale. So in those cases you would like to go for a database like HBase. So HBase runs on yarn, as well as it basically, on HBase you can run your logic parallelly. Please note that HBase is not really a database. And why I say so? Because unlike database, HBase does not provide a query language, neither DDL nor DML. DML as in data modification language and DDL as in data definition language. So unlike your traditional databases, HBase does not provide the full-fledged relational structure. And that's why it would be unfair to say that HBase is a database. Instead, it's more like a data store. All right? So for example, all the information about the web pages, that which web page is linking to which one, is all stored in HBase. Okay. Similarly, in case of Facebook, if I am designing Facebook and I have to maintain everybody's status, I will use HBase. Now, what is the difference between pig? What is the difference between pig and hive? advantages, disadvantages of each. So yes, we will go into those details when we study both. To you, as of now, it'll all look like words, but we will go into the details when we actually do something on Hive and Pig. Okay? In simple words, Pig was designed for parallel or distributed computing from bottom up, while Hive has been designed so that the people who are comfortable with SQL can continue the work. Okay? So Hive basically was kind of an arrangement while Pig was designed for Hadoop. Okay, that was a question from there. And another one question from Pankaj. HBase and HDFS both are used to save data. Then why we need both? My question to you is MySQL and your file system like C colon both are used for storing data. And why do we need both? Yeah. The reason is the reason is HDFS is good for unstructured data, while HBase is better for structured data that requires constant modifications. So in HBase, you have the tabular structure, while in HDFS, you have file system. All right, there's a question from Joanne. Where part of these components you could create your data set? Where part of these components you could create your data set? I did not get your question, Joanne. Could you be a little more? Could you help me understand a little bit more? Which part? Probably you mean to say which part of these systems you could create data set. Okay, there is a question from Shashi Agarwal. How do you read structure of HBase? You can read by querying HBase. HBase provides you an API as well as a command prompt. Dilshad's question is, do files have HDFS? Do files in HDFS has extension? Can you share one example how they look like? All right. Before I keep on repeating myself again and again, let me try to show you some things. Okay. I think this is better to actually show you um, rather than you know. Okay. Let me take you to my cloud labs. I think that is easier to explain. All right. So my courses and were you all of you login into your my account and see my courses? Those who have enrolled will be able to see it. All right. Now here, all right, your account, your passwords are yet to be created, but I will just use this one. Okay. Or maybe I'll use. Ouch. Just give me a second. All right. So I need to go back and alright, let me try to log in using another account. So account for each one of you will appear in your system, as in when you log in into account, and it will be done by tomorrow. Alright, I'm not able to log in. Oh, I was not pressing caps lock. Alright. Actually, I can't show you the password because it's getting recorded. That's why I have to type it. Alright. Now you can see that this is our cluster. It's running all the components which we have talked about. There are a few more components which we will discuss as we go. Okay. So you can see there is a HDFS and it's running on three computers parallelly. It says 3 out of 3 are started up. And this is what is going on. You have MapReduce running in, you have Yarn running in, you have Hive running in, and Pig doesn't have a server. Pig is only client. It translates the Pig query into HDFS, and you have HBase. In HBase, this only some part of it is running. We can start it easily. Okay, you can start it easily. If you want to query the HBase, then we have an interface for that. All right. Now let's go ahead with the this is called, by the way, this is called Ambari. Ambari helps you monitoring the cluster, and Ambari also helps you installing various components and machines. Okay, so now let's go to interact with HDFS. Okay, our HDFS is running here. Now in this, you can see that there is something called query editor. Alright, let me start from the beginning. Let's go to the file browser. This is our file browser. This is where we store data. And what is this? This is HDFS. Now you can see many things. Many things will get clear. So HDFS is actually like your normal database. You can see, HDFS is like your normal file system. You have folders and you have files. You can see that you have files, you have folders, and so on. Okay, so every user has their own folder at this place, like this. All right. So you can see the content of the file from here. This component using which we are interacting with HDFS, it is called Hue. The earlier one was Ambari. This is called Hue. This Hue helps us interacting with HDFS. If you want to see what's going on with your MapReduce, you can actually go to the even the workflows and then see how can you execute the queries. All right. Saroja, does that make sense to you now? So these are the workflows which are running, stopped, completed, and here you basically create your program and schedule, create your workflow and schedule it. Yes, these files which we just showed you can be viewed from the file system but using only the command like Hadoop fs minus ls. Okay, we'll go into the commands in the second session. All right. So this is your HDFS. This is your HDFS, and let me see if I can show you the HBase. Okay, HBase master is anyway down, so it won't be possible. It'll keep on giving errors. Cannot connect. See. All right. So yeah, I just need to log in from admin and then fix it. We had been experimenting with HBase lately. That's why you'll see HBase is down. Okay, so Pankaj, does it make clear that what is HDFS and HBase? HDFS is more like file system where you upload files, and HBase is more like a database table. No? Now, I'll answer John's question. Which part of which part of these components do you create your dataset in Hive, in HBase, okay, and in Pick? How do you read the structure of HBase? You can either use the command line, okay, use Hue, or use Java. All right. Next is, so do files in HDFS have extensions? Just like normal files. So Johan, not Johan, Shashi, was I able to answer your question? And Dilsad? The question from Kamal is, so how do we modify in HBase if we do not have DML? So the kind of DML we have here is very, very primitive. Okay, very primitive, very simplified in the terms of key value. It does have DML, but very primitive. It's not like standard. Yes, Saroja. So yeah, Saroja's question is, can you please show some of the projects done in previous sessions? Yes, we can show you. And we have also posted on our YouTube channel. You can have a look at it. All right. Next question from Anand is, These files can be viewed from the file command line as well. Yes. So you can go to command line. I'll show you. So you can go to SSH root CloudX lab. So I'm logging into my CloudX lab. Okay. From here you can see Hadoop fs minus ls, and let me show you exactly the same file which we are seeing here. Okay. Let's see if I say Hadoop fs minus ls slash, okay, or user bin, okay. Let me try searching where is Hadoop stored. Oh, oh, sorry, I'm on the wrong server. I have to be on H1 because, okay, now if you say Hadoop fs minus ls slash, now you can see app logs, apps, data, HTTP, MapRed, MI history. Yeah, this is same as this one. Okay, you could go to app logs and you have Ambari QA. Okay, or let me just show you apps logs. You can see there are two folders like this. Alright, next question from Anand is where our source coded, I mean MapReduce and Spark program which consumes the data and computes resides. It basically first, mostly you will be working on your desktop with the code, and then so you might use Eclipse on your desktop, okay, and then you will upload to a workflow engine such as Uzi. This is how it works. You will upload your code to Uzi or something like that, and then it will work. All right. Next question is, does this course include how to set up Hadoop environment like packages etc? No. We give you a basic overview of how to install using Ambari. Okay. So we'll give you a basic overview how to install the cluster using Ambari. All right. So Cloud Lab is based on Hortonworks or Cloudera. So what we have done is we have taken installed Hortonworks platform plus some components of Cloudera. Okay, there were some components which were missing from Hortonworks system, so we removed them. We added those in the Hortonworks, such as this file system is not available as part of Cloudera offering. So we install as part of Hortonworks. This file system is not available. So we installed it extra on our Hortonwork platform. So REST is all of this. If you go to h1.cloudxlab, this one is Ambari, and it is basically the whole Hadoop platform. But this file system is from Cloudera. So we have taken the best of both worlds and installed some more things on the cluster. All right. Another question from Pankaj is when to use Ambari, Hue, and console login. So you use Ambari for monitoring, monitoring, administering, okay, and you use Ambari for monitoring, administering. So you install things using Ambari, you monitor servers using Ambari, and also you add provision, we call it provision using Ambari. You interact with services, okay, such as HDFS. So you can create file, upload data into using Hue, but you can't do that using Ambari. Okay. Now console is generally for those people who like the command line interactivity and not the browser. So for more or better engagement, I generally prefer to use console. Say for example, in case of HBase, if I open the console, it's far more faster. The response time is really, really faster. Okay. So those are the three use cases. Okay, let me just write it down. Not all services are available for interaction using Hue. Uh, is Ambari a performance management tool? Kind of, yes. All right. So this is our file system. We can create our own files, upload our own folder, and whenever we are churning data, that output will be here only. We'll be saving all the outputs in the file. And when we will be doing exercises, most of the data would reside in this folder called data. All right. Since we are upgrading the version of our Cloud Labs, that is why the Cloud Labs, the new logins are not available right now, but they will be available by today afternoon. Did I miss anybody's question? Saroja, were you able to get the question answered? Zuan, Kamal? All right, going back. So, so we have all of these components here, and yeah. If you generally have to see right now there are three hosts and we'll keep on adding more and more hosts as we go forward. Here there is generally a button called click here to add hosts. So all you have to do is add host and you give the IP address of the computer on which you want to install Hadoop, and all of these services will get installed whatever you select. All right, any questions at this point? Yeah, so we talked about all these components. We talked about HDFS, we talked about compute engines, we talked about HBase, we talked about Hive, we talked about Pigletin and Mahot. Now there are two more components in the bottom. With one is called Flume. Imagine this: you are running a web server, and continuously, as and when the data is being generated on these web servers, you want to push it to HDFS, because Hadoop distributed file system is very reliable, scalable, and distributed. Therefore, therefore, it makes sense to move almost all the unstructured data to HDFS. Okay, but how would you do that? For that, there is a tool called Flume. Using Flume, it's actually possible to build complex data flow schemes such that the data keeps flowing to the HDFS. All right? And sometimes you have the traditional systems, you have the relational systems like Oracle, MS SQL. You would like to move those systems to you will like to move the data from those systems to HDFS, Hive, or HBase. In those cases, you will use Scoop. Or let's say you are done with generating recommendations and now you want to display it on your website. To do that, you will have to first generate the recommendations, prepare the data in a tabular format, and then use Scoop to take this data from here, from HDFS, to your MySQL, to your database which is running in the production. Okay, you will have to do that, and for those kind of thing you have Scoop. So whenever you have to take out the data with or you have to talk to HBase to talk to any relational databases, then you use Scoop. But if you have unstructured data that is flowing in, you can use Flume. Okay, now sometimes or most of the time, actually most of the time, in a bigger project you will have many things to execute. Let me take an example of my let me take my example of my recommendation engine. Okay, let's take about recommendation engine, which basically prepares recommendations to various users based on their past history. So first step was to bring data to HDFS. For this, you use Flume. Second step was, once we brought the data into HDFS, to clean the data or parse the data. I call it parse the data. Parsing the data and ignoring some records and cleaning it needed proper map reduce. Okay, it was the raw map reduce. Third was further processing that was done using Hive slash pig. Number four, once we were finished cleaning the data and we were finished further processing using Hive and pig, we moved on and fed the data to Mahout. Now Mahout gave us recommendations. Fifth was to take these recommendations and save it to DB. Okay, take these recommendations, save it to say MySQL database. Okay, for this we used Scoop. Now if you see, even in this small project, we utilized Flume, MapReduce, Hive slash Pig, recommendation, and Mahout and Scoop. Now how would you tie these things together? That's where Oozie comes into play. There's the role of Oozie here. And you can interact with all these components either using command line, using Java program, or using Python program, or using any other language for that matter. Alright. Now, question from Anand is, in this example shown there are three nodes connected. HDFS files, what we are seeing in the Ambari is there in all three nodes. Yes. Alright. Some parts in one, some parts in another, and some parts in third one. Yes. Yes, Saroja, you will get the URL. Pankaj's question is, Flume and Scoop both are used only to export data to HDFS from store or import export from data store to both import as well as export. Okay, so these tools are from both. You see the direction of the arrows is both. All right. So Cloud Labs, we have seen already that there is something called Ambari Hue, and if you want to see, there is a console as well. You can go to H1 and you will see the console. All right. Now after logging in, you can start working with Hadoop components. All right. Good. Good. All right. Those who are a member who are already enrolled, please go through Ambari console. We will update the password quite soon. And those who are not yet enrolled, you can enroll directly. Go to courses, and then please finish the quiz. Try to finish the quiz. You will be able to finish first 10 questions. Okay. Please try to finish first 10 questions. Pankaj's question is, do you help in installing VM? Yeah, we can help you definitely. Yes. Okay. If you get stuck, let us know. All right. But we are not big fan of virtual machines because the learning experience of students is not great with virtual machines. You should generally use the cloud labs because that's how it happens in industry. Okay, that's how it happens in industry. You generally use a okay, centrally stored cloud labs. All right. Now, Murukesh's question is, link for the quiz is here. You can go to the LMS, and here you can click on the quiz and start. All right. All right. Yes, we will email you with the URL links. Yeah. All right. Thank you very much. We are running 5 minutes late. All right. If you have not enrolled and you're planning to enroll, you can just go to the website and enroll. There are only few seats left. Okay. There are only few seats left. Okay. You can enroll from here, from the website. Saroja's question is, can we switch between Cloud Labs and VM? Of course, you can switch. Okay, it's the same environment. It won't be too much of a difference. All right. Thank you, Murukesh. Thank you, Harita. Thank you, Kamal. Thank you, Anand. Thank you, Carlos. Thank you, Dilsad. Thank you, Dripu. Thank you, Dev. Thank you, Juan. Thank you, Kamal. Thank you, Lokanath. Thank you, Lokandham. Thank you, Nilesh. Thank you, Pankaj. Thank you, Peter. Thank you, Ravi Teja. Thank you, Rohit. Thank you, Saroja. Thank you, Shashi. Thank you, Shyam. Thank you, Chiu Tong. Xiao Chiung Tong. Thank you, Sumati. Thank you, Vilma. Have a great day. Bye bye. All right. If you have any questions, please feel free to get in touch. All right. And our email ID for the support for those people who have already enrolled, you can just connect at this email ID, and these are our phone numbers. All right. So today's recorded session, for those who have enrolled, it will appear in their My Courses, and for rest of the people, you will get it in the email. Yeah, VM setup. We have a document here. You can go to My Courses and try to install it from My Courses. If you go to say this particular course, and in here you have the link for the installation instruction. You can install it from there. All right. Yes, you will have access to these lectures in case you miss anything. Yeah. All right. Bye bye. Have a good day. Feel free to stay connected. Saroja, you can enroll from the website itself. Bye bye. See you then. Have a great day ahead. Bye bye.